All right, so this is, okay, they're saying hi. Hi. Okay, so this is the 5-6 lesson on inverse trig functions, taking the derivatives. So first, let's review of what we know about inverse trig functions. Remember that none of the 6 basic trig functions have inverses because they're not one-to-one, correct? Okay, so remember that when we did this, I don't know if you did this in 2-trig or pre-calc, but you had to restrict the domain of each of your inverse trig functions. Remember that? Okay. And then if you look on page 371, there's a chart that talks about that domain, but I really want to look at 372. Those are those graphs of the inverse functions. So I'll pull those up here as well. So you can see that these are those inverse trig functions. So remember that this is the inverse sine, and that has the domain restriction of negative pi over 2 to pi over 2. Well, the original is restricted from negative pi over 2 to pi over 2, but that becomes the new range. Okay, and so on. And this is cosine, this is arctan, this is arcsecant. No, this is arccosecant, this is arcsecant, and this is arccotangent. All right, so just a reminder of those restrictions when you're doing that. So remember that it helps when you're evaluating any kind of inverse trig function that you just think of it as the angles whose tangent is blank. Okay, so let's look at some examples just to remind ourselves. So for example, move this out of the way. Ugh. If I wanted to do arc sine of negative 1/2, I'm thinking what angle has the sine of negative 1/2? Okay, and remember our range has to be between negative pi over 2 and pi over 2. Okay, so this should really be negative pi over 6, not negative 30, but that's okay. We'll overlook that. All right, same thing with this. Arc cosine. Okay, so what angle has a cosine value of 0? Yeah. Pi over 2. Okay, so are we familiar with that? That coming back to us? All right. So this note on page 373, I think it's important to remember. It's just that paragraph right above that box. So all it says is remember that this property that says that the inverses of each other, if you compose those inverses, that you equal x. That's only true when you're in that proper domain and range. Okay, so for example, it says arc sine of sine of pi. That's not pi, right? Normally we think, oh, those would cancel each other out and that's pi. But pi is not in the domain of that's restricted. Okay, so we would have to do that manually. So, wait, I did that backwards, didn't I? Okay, so sine of pi is what? 0. Sine of pi is 0, and then so the arc sine of 0 is 0. Yeah. So not 0. It's just 0, right? Okay. It's not pi because pi is not in the domain or the range of arc sine. Okay. So we're good with that? Okay. And also remember we use these to solve equations like this, right? If I wanted to solve this arctan of 2x minus 3 equals 1 pi over 4, then we just would take the tangent on both sides, okay? And which is fine because here we've got the tangent of pi over 4. Okay, so that just gives us 2x minus 3 equals 1, and then we can solve. All right, so this is all review. Okay. Another application is to use it in right triangles. Okay, so remember that if I wanted to solve this and find tangent of y, I could draw a right triangle. So I would say, okay, I want some angle. Here's my angle. And the secant of that angle is square root of 5 over 2. So remember, secant is just, no, the other way around. Hypotenuse over adjacent. So that would be square root of 5, and then the 2 would be there, right? And then what could I do to find this third side? Pythagorean theorem. So we're going to get 1. All right, so if I wanted to find the tangent, I could just use that triangle, right? So the tangent of that theta would just be 1/2. Okay. Any questions about that one? Okay, so we're going to move on and talk about these problems, numbers 21 through 28, but we're just going to do a sample problem. This is on page 377, number 22. And it says we want to find the secant of the arctan of 4x. We're going to write this as an expression. Okay, so we're going to set up a triangle. Remember, if I say arctan of 4x, I'm trying to figure out which angle has the tangent that's 4x. So I'm going to have some angle, I don't know what that is, and the tangent is opposite over adjacent, so that's going to be 4x over 1. Yes? Okay, so how would I find the hypotenuse? Pythagorean theorem. So I'm going to do 4x equals RC squared, so that's what my hypotenuse is. Yes, sorry, that equals C. Okay, so we've filled out our triangle now. So now what we're going to do, I'm going to get rid of this Pythagorean theorem stuff so I have more room. What we're going to do is we're going to find the secant of that theta. Because the arctan of this is just this angle, theta. So I'm going to find the secant of theta. So like all of this is like theta, right? So we're doing secant of theta. What would that be? Hypotenuse. Hypotenuse, which is, 16x squared plus 1 over 1. Yeah, the adjacent. Okay, so you don't have to write the 1, you could just write this. So notice that we didn't have an actual value, we just had an expression for the secant. We're good with that? Oh, good. So that's kind of a review of the pre-calc or the trig or whatever, whenever you guys learned that. Now for the calculus. So flip your page over. Okay, so these formulas are actually on page 374. So you can look that up. They're in a blue box. But what I want you to notice is that, here, I'll pull them up. So here's the blue box on page 274. Okay, so yes, it seems like a lot, right? We're gonna go through how they derived these, though, just so you understand where they got them, so you're not just like random stuff. But do you notice how all of these ones that start with co are just the opposites of the other ones, of their cofunctions? Okay, so like cosine is just has a negative in front of the one that's sine. So you're really only memorizing 3, not all 6. Okay. So maybe that'll help your anxiety there. All right, so let's look at how we came up with those 3. So I'm going to extend. All right, so let's look at inverse sine. So if I have y equals arc sine of x, remember that's the inverse of sine, right? So what did it look like in just regular sine form? What would that be? What does this really mean? This means sine of y equals x. Yes, sine of y equals x. So I'm going to write it like this. Okay, I'm going to use this form because when I find a derivative, I know how to take the derivative of sine. I don't know yet how to take the derivative of an arc sine. Okay, so that's why I'm doing it in this form over here on the right and not on the left. Okay, so if I take the derivative of both sides, so I'm taking the derivative of that whole thing, what would I get? I would get 1 on the left side, cosine of y, yeah, dy dx. I'm going to use y prime. Are we okay with that? So this is the derivative of sine of y, and then times the inside. We're doing chain rule or implicit, okay, dy dx. So I want to actually get y prime by itself. So I'm going to have y prime is equal to 1 over cosine of y. Okay. Now, here's where the triangle comes in. I actually want to, I'm going to draw a triangle and write cosine of y as an expression, just like we did in that last example. So I'm going to draw a triangle up here. And I'm going to have this angle. And remember, this is saying that the sine of some angle is equal to x. Okay, so the sine of this angle right here is going to be x over 1. No, sorry, that's tangent. Sine is opposite over hypotenuse, right? Okay, so that's x over 1. So I need to write this third side. So how would I write that third side?
How did you get x from 1?
From here. So the x and the 1 came from here.
1 minus x squared.
Pythagorean theorem. So I'm going to have the square root of 1 minus x squared. So if you do Pythagorean theorem, you'll get 1 minus x squared. Are we okay with that triangle, how we came up with that? Okay, so now, okay, instead of calling this theta, I'm calling this y because that's what they called it here. They call this angle y, so I'm going to call this angle y in my triangle. That way it'll have more consistency. So when I try to write cosine of y, I'm going to use that triangle. So what can I replace cosine of y with? Good, it's the adjacent side, that's square root of 1 minus x squared over the hypotenuse, which is just 1. Okay, so I'm not going to write the 1. Okay, so now what I want you to do is look at your book. Isn't this what the derivative looks like for arc sine? Okay, it looks like u prime over 1 minus u squared, right? This is the x version. If you had u, you would have the u prime.
How come cosine u, or cosine y?
How come it's that? Remember that cosine of y is the adjacent, cosine is adjacent over hypotenuse. So this is y. Y is the angle. Okay. So let's do one more, and then you guys can do one on your own for fun. Let's do y equals arctan. Okay, we're trying to find the derivative of this. So again, in order to do the derivative, I'm going to rewrite this in terms of tangent, not arctan. So how would that look?
Tan y equals x.
Good. Tan y equals x. So I'm going to take the derivative of both sides. That gives me 1 over here. What's the derivative of tangent? Secant squared. No. Yeah. Secant squared. Times y prime. And so then I get y prime is equal to 1 divided by secant squared. And here's where I want to rewrite. I want to go back to a triangle. So if I go back to a triangle from over here, remember this is going to be this is like x over 1. So I'm going to draw my triangle. My angle is y, and I'm doing opposite over adjacent, x over 1. So what is my hypotenuse going to be? Good, square root of x squared plus 1. I'm going to just write 1 plus x squared, because that's how I have it. Okay, so then, yeah, I want to rewrite secant squared. Remember, this is like, secant squared is just like secant and then quantity squared. So I really just want to know, what is the secant? What can I fill in for the secant?
Root 1 plus x squared.
Good. So it's going to be my hypotenuse over adjacent, and so that's just root 1 plus x squared over 1, but I'm not going to write the 1. Are we okay with that replacement? All right. So we've got y prime is equal to 1 over, I can square the square root. So this is just 1 plus x squared. So if you look at your chart again, on page 374, that's what the derivative of arctan is. Okay, except with u's. Yes.
Oh, wait, never mind.
Okay. All right. So are we okay with how they're coming up with this? It's not the most intuitive thing, but that's okay. All right, so some examples just so you can see how they work. So if we're looking at this first example, we're doing derivative of arc sine of 2x. So what is the u? The u is the 2x. So the du, or the u prime, is just 2. Okay, so if I take the derivative of this, I'm going to have 2 on the numerator, and then I'm going to have the square root of 1 minus u squared. So here's the 1 minus u squared part. And then that's just simplified. We're good with that? Okay, and then here's another example with arc sine. So again, your u is, here our u is square root of x, and what's your du?
1 over 2 root x.
So that's where they're getting this part right here. And remember, this was 1 minus the square root of x squared, so that's where they just got x. So if we simplify that, so we brought the square, this x to the negative 1/2, we brought that down here, we brought the 2 down. And since both of these were underneath the square root, they just distributed. Okay. Any questions about how we're using those formulas? Okay. We're going to try these problems. So they're on page 378. First one we're going to do is number 42. Okay, so on the number 42, it says f of t, f of t is equal to arc sine of t squared. And we're just trying to find the derivative. Okay, so I'm going to give you guys time to try that on your own. Okay, so when we do this, what's our format? What do we do? What's our u? T squared is our u, and then du is 2t. So when we do the derivative, we're going to have our u prime, which is du. So that's 2t divided by 1 minus u squared. So that's going to be t squared squared. So yeah, please simplify that. That's not hard to simplify. So that's 1 minus t to the 4th underneath the root. So there you go. That's your derivative. I'll label this. This is f prime of t. Okay, so let's do the next one. Number 52. Number 52 says y is equal to natural log of t squared plus 4 minus 1/2 arctan of t divided by 2. So again, I'll give you some time to... Okay, so we're ready to go over this one. So when I do the derivative of just this ln part, what is that? Du over u. So I'm going to have the du. Remember, on this part, my u is t squared plus 4. So my du is simply 2t. So my derivative of the ln part is t squared plus 4 in the denominator and 2t in the numerator. Okay, then we have over here, we have the new stuff. So what is my u for the arctan part? Yeah, t over 2. So my du is 1/2. So we've got our 1/2. Then my derivative of arctan has the du part in the numerator, and then the 1 plus u squared in the denominator. So when we simplify this, it actually comes out really nicely. So I'm going to bring this 1/2 down here. So I actually have a 1/4 to distribute to this. Right? I don't like the way I wrote that. So this is just t squared over 4. So when I distribute that, I get 1 over 4 plus t squared. And so this one is t squared plus 4. So they have the same denominator. So when we combine those together, we just have 2t minus 1 over t squared plus 4. And that's our derivative. All right, so your homework tonight is going to be page 377, numbers 3 through 33 odd, 41 through 53 odd, 61, 67, 71, and 73. Okay, we're going to say goodbye.